Okay, I'm back, and so now what we want to do is add two waves together. And so in this picture over here, we've got wave A, and we're going to add it to wave B. And so that could be on an exam, to where I give you a particular wave, and so let's say that I'm trying to reproduce the one that's over there. So that's going to be wave A. And then underneath it, we're going to have wave B, and we're going to add it together. So this one's going to go down, and then it's going to be coming back up when this one is going down. So something like this. So that's pretty much a good representation of it. And here is B, and we're going to add the two together, and we're going to end up with graph C. So how would you do it if you had these two waves and you want to do this one, but you've got a ruler? Well, I did it for two of them here. So I'm going to have a line that's going to go down like this. So I could draw a line with my ruler there. And then I also did it over here where it's not matching up very well, but let's go ahead and do it anyway. So let's say that I'm picking this line right here. So now I get out my ruler and I measure this distance from here to here, and let's say that it is going to be, oh, it looks like it's about 1 centimeter. But notice that this line is below this line here, so we would refer to it as being negative 1 centimeter below the line. And then over here, notice that this one looks like to me that it's about 3 centimeters above the line, so this would be a positive 3. Now we're just going to add them together. So 3 plus negative 1 is the same as 3 minus 1, which is going to be 2. So that means I need to measure up 2 centimeters up to right about here, and then I just put a dot. Okay, now let's do this one over here. Now this one is not the same one that's in that picture, but I deliberately chose the line so that it went right through here. So if that's where it intersects the horizontal line, how far above the line is it? Well, it'd be a 0. So we would say that this one is 0 centimeters. And now this one down here looks to me as though it's like a negative 3 centimeters. So we're going to add the two together. So 0 plus negative 3 is negative 3. So that means that I need to go down 3 centimeters and again put a dot. So what I'm going to end up doing is I'm going to have a whole bunch of lines like this, and then for each of those lines I'm going to have a dot on it, and then I just need to connect the dots. And then when I do that, I will get wave C. So wave C is what happens when you add wave A to wave B. It takes a long time in order to do one of these things. And the more lines that you have, the better it's going to be, the more accurate it's going to be. Well, I wanted to show you a computer program that can do it for you. And so this is found at www.geogebra.org/mbombfink. All right, so go find that website for me. All right. So pause me while you're finding that website. And so I just happen to have it right here. And so what I want you to do is to just play around with these sliders over here. So you've got blue sliders, and then you got green sliders. All right, so I want you just to move the sliders back and forth, and I want you to see what it does. Okay, did you do that? So for example, if I take the blue one up here and I move the blue one back and forth, what is that changing? Well, first of all, notice it's changing the blue wave. So these sliders over here are going to be changing properties of this blue wave, and then these sliders over here are going to be changing properties of the green wave. So the very first one is changing the height of the wave. So what's another name for the height of a wave? Begin with the letter A. That was the amplitude. So you can change the amplitude of the blue one or the amplitude of the green one by using those sliders. Okay, then what about this one? So this one, okay, you can see that what it's doing is it's going to be moving the wave back and forth, but notice it's not changing the wave length and it's not changing the frequency. All it's doing is it's picking up the wave and moving it from side to side. And so that, in physics terms, is going to be called the phase angle. And so what you could do with this is, again, let's move the blue one. I could move this blue one so that, do you see that when it starts, which is right here at the origin, it's at 0. But if I wanted to, I could also move this thing so that when it starts, it is at its maximum. So this is called the phase angle, and it's a very useful thing, and we can move it back and forth. Now, incidentally, these equations over here are the actual equations for the wave. You do not need to know that for in this course. But if you decide to go on and take more advanced physics courses, you would find out how to mathematically picture this wave, and it turns out to be a sine wave. And so it has, the amplitude is the number that is coming in front of the sine thing, and then inside these parenthesis things is going to be the thing that's related to the frequency of the wave, and then also the thing that's related to the phase angle. Don't worry about it. I'm just telling you that we could mathematically describe these waves using sine functions. So then that leaves us with this one here. So what does this one do? Well, you can see that it's scrunching it up and it's making it larger. Well, we could say that it's changing the wavelength. So the wavelength is going to be the distance from here over to here. So that was the wavelength lambda. But we could also say that it's changing the frequency of the wave, because we had another formula that said that the speed v of a wave was equal to its wavelength times its frequency. So that if the wavelength gets small, then the frequency gets big in order to compensate. And so you should notice this, that as we make the wavelength, the distance between the waves, if we scrunch it up, notice which way do we have to move the slider in order to do that. And you'll notice that we're increasing the frequency when we do that. So go ahead and try it. Just don't take my word for it. Go ahead and do it. So now we've got these two waves, and we can change their amplitude, we can change their frequency, we can change their phase angle. But the goal is to add them together. And so in order to add them together, all we got to do is click on that box right there, and then that red line is C. So that red one is what happens when you add the blue one and the green one together. Now I want you to prove this. So let's say that we take this line right here. So I want you to measure, you could use the numbers that are there on the screen, but measure the height to the blue one, measure the height to the green one, add them together and see if it's not the height to the red one. And then if you want, you can do it for other places on there. But notice that we had a nice sine wave for the blue one and a nice sine wave for the green one. But when we add it together, do you see how it's making that kind of a weird looking pattern? So that's a hallmark of adding two waves together, is normally you're going to end up with some completely different looking wave. So what would be an example of this? Ocean waves. So that, let's say that you have an ocean wave off the coast of Australia, and it has a nice looking wave that's being generated by wind blowing across the ocean surface. But then, and again, let's say that this wave in Australia is moving north. So the wave is being created off the coast of Australia, and the wave is traveling north. But then let's assume that off the coast of Hawaii, you have a different wave that's being generated because you're going to have different winds off the coast of Hawaii, and that's going to generate a second wave. And let's say that it's traveling towards the wave that's coming from Australia. So when those two waves meet with each other, it's going to give a very odd looking wave that's going to be a combination of those two waves. And especially if you have storms, you can have waves in the ocean that are coming from multiple directions, and each wave has its own wavelength and frequency. And so that's the reason why ocean waves look really weird, is because they're a combination of many, many different waves. Your voice is the same thing. So your voice is not just one wave. It's multiple waves being added together to make your unique voice pattern. So it's just like fingerprints. Everybody has a different voice pattern. Even a ventriloquist. So the best ventriloquist in the world, if they were to imitate some famous actor, and then you were to compare their squiggly line created by their voice to the squiggly line created by that actor, they don't match. So you cannot, it can sound like the other person, but you can't fool a spectrometer or a device that would be able to separate the sound into its component wavelengths. Okay, got that? So now you know how to add waves in general. So let's go back to the notes, and now our next goal is to add identical waves together, and we're going to do that in our next segment.